So I told you, okay, that I want to actually continue with the Hess's law. Yeah. So this part, okay, for Hess's law is a very important part. Okay. You need to really understand this concept, okay, of Hess's law. Okay. I will go through, okay, whatever things that I actually went through yesterday. I will go through again, see we can try to get everything sorted out properly. So you see, Hess's law, okay, is actually defined as total enthalpy change, okay, is independent of the route, okay, as long as the initial and final conditions are the same, okay. So if let's say if you are having something, this is as A, okay, A is going to react with B, okay, let's say when there is a particular reaction where A reacts with B, they're supposed to give you C, for example. Okay, they're supposed to give you C, and that is going to be enthalpy change number one, for example. But okay, in chemistry, there are certain situations where you can have multiple reactions, okay, that can happen instead of going directly to C. Okay, for example, instead of going directly into C, we can also have another reaction where, okay, A plus B, maybe they give you D first. After giving you D, maybe the D will change into C. Okay, so there are two steps, okay, to reach to this. So this is what we say, different route of the reaction, different route. Okay, so it's a different route. Okay, multiple routes can actually take place. So in order to do this, maybe let's say this one is going to be pathway number two, okay, enthalpy change number two, and this is going to be pathway number three. So I put enthalpy change number three. Now, according to Hess's law, okay, Hess's law stated that, okay, the total enthalpy change is independent of the route taken. Okay, this is going to be the total enthalpy change from A to B, A and B to give you C. Okay, this is going to be enthalpy change number one. It is also the same, okay, because it's independent. Yeah, whatever pathway that you take, as long you reach to C, it means that this is going to be the same as enthalpy number two plus enthalpy number three. This is actually explained by Hess's law. Okay, so according to this law, okay, that is the explanation. But according to the definition, that is the explanation. But how do we actually put it in a sense that I want to actually apply this concept of Hess's law? So we need to come up with a way to apply this. Okay, how do we get this? So this one, okay, if just take it as you have a circle here. Okay, and in this particular circle, okay, so you can actually if I use a different pen, different ink over here, if I'm going to actually make this arrow, okay, the arrow for h1, okay, the arrow for h1, okay, let's say I try to curve the arrow a bit. Okay, the curve the arrow. Okay, it's a straight arrow, but now I'm curving the arrow. Okay, so this arrow that I have curved, okay, is still going to be h1. Okay, still going to be h1. So I'll put it as delta h1. Still going to be h1. And then I do the same thing, okay, for this. Okay, I curve the arrow, and this is going to be like this. This is going to be representing enthalpy change number two. The same, I try to curve this arrow for h3. That's going to be my enthalpy change of number three. Now this one, okay, please actually take note. We are going to assume, we are going to use Hess's law in this way. Okay, clockwise direction, okay, is always going to be the same as anti-clockwise direction. This is the way to apply Hess's law, right? So if you look over here, okay, can you tell me, Sharon, which one is clockwise curve over here? H1, H2, or H3?
H1.
Okay, so H1, okay, is there any more clockwise arrow over there, Thompson?
No.
No. So this is equals to anti-clockwise. Anti-clockwise, you can see the H2 and that is going to be H3. So you just need to plus, okay, H3. This is the same, okay, where you get it from, okay, the Hess's law definition. So it means now, okay, Hess's law, whatever that you use, yeah, the method that you use, which is going to be clockwise equals to anti-clockwise, is just an extension of Hess's law. So we still keep in our mind, we are following Hess's law, yeah. So to actually put it in application, okay, I have these three examples here, okay, three equations. Okay, let's actually work out on these equations. Like for example, write the equation for enthalpy of formation of SO2. So Nathan, can you actually define for me enthalpy of formation?
Enthalpy of formation, sir.
Yes. Is the enthalpy change when 1 mole of
When one more of
compound,
form from its element.
1 mole of compound is being formed,
Yeah, from its elements.
From its element under what? The element must be under standard solution. So the compound that we are talking about is going to be sulfur dioxide. It's a gas, okay? It's a standard condition. So you are getting this from sulfur plus O2. These are the elements involved, okay? And they must be in standard condition as well. So the condition is going to be gas for oxygen, but given, can you tell me sulfur at 25 degrees is going to be solid, liquid, or gas?
Is it solid?
Is solid, yeah. Okay, sulfur is always solid, okay, at 25 degrees Celsius. So this one, okay, I randomly picked this number over there, negative 20. So later I will use that number. Okay, let's say one of the number I will erase here. Let's say I erase this part. I don't want this for now. Okay, so I have this equation. Okay, I have this equation. And let's actually write the enthalpy, enthalpy of combustion. So combustion, Frederick, can you define enthalpy of combustion?
The enthalpy change of 1 mole of oxygen.
No.
Yeah.
It's the enthalpy change when 1 mole of
the enthalpy change when 1 mole of oxygen is formed from its element under the standard.
No, Frederick, no. It's the when you put of combustion, you are trying to burn 1 mole of substance. Yeah. So the substance that you want to burn over here is going to be SO2. You are trying to burn with excess oxygen. Okay, not 1 mole of oxygen, excess oxygen. Okay, to give you the product. So in this case, this is you are going to get SO3. So this is going to be under standard condition. So here, okay, this one, since we want 1 mole, it means we do not want to mess up the number of moles in front of SO2. I need to balance the equation. I have 3 oxygen here. So how do I actually balance the equation, Michelle? What do I need to put in front of O2?
Half.
Okay, you put half, okay. Then you get 1 oxygen plus 2 oxygen, you get 3 oxygen over there. So this is already balanced, and then this must be in gas, must be in gas, must be in gas, because they are under standard condition. This is going to be the situation. Yeah. So that is done, and this one is going to be negative 30. Okay. So write the equation of enthalpy change of reaction of sulfur burned to give you SO3 gas. Sulfur burned to give you SO3 gas. Okay, so gas, I know that this is always solid, this is gas. So I need to actually come up with an equation. So in order to get 3 atoms of oxygen, so it's going to be 3 over 2. I put 3 over 2 there. Okay, so this one I do not know. Okay, let's say I put X. Okay, I put X. Now I am going to show you how do we use these 3 equations, okay, to show that, okay, we can use the Hess's law, or we can form what we call as Hess's cycle. This is called Hess's cycle. Okay, so we are going to try to use this equation number 1, equation number 2, and equation number 3 to form the Hesse cycle. Okay, so in order to do that, okay, I will start with let's say number 3. Yeah, I'll start with number 3. So I will write down first. Okay, probably I don't want to be lazy, so I'll just put it in this way. Okay. Okay, so I have this. Okay, I have this. Okay, and this one you should know that just now I mentioned this is going to be x. I do not know. Yeah, I do not know. Now I have actually equation number 1 and equation number 2 also. Okay, and if you can see the equation number 1, okay, is going to be sulfur plus O2, okay, to give you SO2. Okay, it means 1 mole of O2. Yeah, 1 mole of O2. I can actually put this as an extension. When sulfur, okay, here I have 3/2 O2. Okay, 3/2 O2. It means I can also write it as sulfur plus 2/2 O2 plus 1/2 O2. It's the same as 3/2 O2, right? So if I have sulfur plus if I have sulfur plus 1 mole of O2, okay, sulfur plus 1 mole of O2 is SO2. So it means you are going to get SO2. Okay. But Sharon, what is left behind?
The 1/2 O2.
Yes. So you put the 1/2 O2 there. That is left behind. Okay. Because we want it to be stable. Yeah. So here, okay, this one we are talking about S plus O2. Okay. Therefore, okay, this is going to be the equation number 1. Yeah. So which is -20. Yeah. Enthalpy of formation. So -20, I'll just put -20 easier. Okay. This is going to be 1 mole, okay, of SO2 is being formed. So it's -20. No need to times 2. No need to do anything. Okay, it's -20. And then when I look at the equation number 2, I can see SO2 plus half O2 to give you SO3, which is SO2 plus half O2 gives you SO3. I put the arrow over there to form that. And you can see everything is balanced. Okay, everything is balanced. And I know that this is 1 mole of SO3 is being formed. So I know that this is -30. It's already given to me. Okay. The screen froze. Okay, let me actually try to connect again. Okay, hold on. Yeah. Okay, just wait for a while. Okay. Here, coming back to what I said just now, this is going to be mentioned is -30 just now. Okay. So what I'm going to put is going to be just put the -30 there. Okay. So from here, okay, using the Hess's cycle, yeah, the Hess's law, okay, the way that I mentioned just now, if you want to put it as a circle, okay, you can see, okay, this one is going to be following this side. Okay, this one will follow this side. This one will follow this side. Okay, so if I put it as x, okay, this is x, -30, -20. So if I put clockwise equals to anti-clockwise, okay, and if I want to calculate now, okay, clockwise is, can you come up with an equation, Wilson?
For clockwise, is it?
Yeah, clockwise. So I think the clockwise is what? X, right? X. Okay, it's already given X. Okay, X. So is there any other clockwise over there?
No.
X equals to? Wilson?
No other clockwise.
Yeah, I know. So what is anti-clockwise now? So x equals to what? So the anti-clockwise is, just put in the numbers. Okay, the anti-clockwise negative 20.
And negative 30.
Yes, and negative 30. So you plus, okay, plus the negative 30. So you are going to get negative 20 minus 30, which is going to be negative 50. So that is going to be your enthalpy change of reaction. So this is applying to the concept of, okay, Hess's law. Okay, now this is one of the method. Okay, this is only one of the method, okay, to calculate, because especially sometimes in your paper 2 they will ask you to draw, okay, the Hesse cycle. So this one is called Hesse cycle. Okay, so we use the Hesse cycle to calculate any enthalpy change. So in the end, we still actually use the clockwise equals to anti-clockwise method. Okay, but if let's say I have the same questions, okay, so we have discussed this, you can use the Hesse cycle for this question, okay, which is going to be the one that I show you just now. Or there is another method which is going to be what I call as magic methods. Okay, my own magic methods over there. It is very useful. Okay, one of the method I think we already use it for clockwise is equals to anti-clockwise here, but later I'll show you another example where you can use the clockwise equals to anti-clockwise using my method. Okay, so one of it we are already learned here. Okay. There is another one way that I want to show you where you can arrange or rearrange the equations to come up with the answer. For example, if let's say they ask you this equation, okay, they say that, okay, they have given you this value, okay, delta H is going to be negative 20, and they have given you this value, and they ask you to find what is the delta H for this reaction. Now, what you need to do is you need to rearrange equations. In order to rearrange the equations, what you need to do is to identify what do you have in your product area, the product or your right hand side. In my on my right hand side, I have SO3. So have a look at the equations that you have. Make sure that SO3 is on your right hand side. So I know that this is the equation and SO3 is on my right hand side. Sometimes you will have a number here, number 2, number 3, and so on. If you have a number over there, what you need to do is you need to times the entire equation with that particular number. And if you do that, you need to also times this value. Okay, but in this case, nothing changed. Okay, so if it is nothing changed, I'm rewriting again the equation. Okay, actually in the actual situation, you no need to do that. But just for the sake of showing, I'm just writing it down. Okay, and I noticed that in my reactant there is sulfur. Okay, or on my left hand side, I have sulfur. And then I see this equation, left hand side there is sulfur, and it's 1 mole. I no need to do anything. So what I do, I just rewrite the same thing again. And this is going to be nothing changed, it's negative 20. Now, what does it mean is, if I have equation number 1 and equation number 2, like simultaneous equation solving in your maths, okay, you can add these two equations, okay, where you can, what will happen is your SO2 will disappear. Okay, SO2 will disappear. You are going to get sulfur, okay, 1 over 2 plus 2 over 2, you will get 3 over 2 O2, your max here, to give you SO3, which is what we want. Okay, if that is what you are getting, it means that you are adding these two, because you are adding equation 1 and equation 2. It means your delta H over here is negative 30 plus negative 20, which is negative 50. This is another method that you can use. Okay, so this is one of the method. Now let's actually try to apply this using questions. But before that, is there any particular questions that you want to ask, or you are not so sure about it? Michael, any questions you want to ask me?
No, sir.
Okay, we will move on, okay, to one example. This example was taken, okay, from your textbook. Okay, I didn't actually take any other examples. I just want you to have a look at this example. Like, this is example that given in your textbook. that they mention about, okay, calculate the enthalpy change of reaction of this equation, okay, of this equation. So what I did is I want to use the method number 1, which is going to be by drawing Hess's cycle. Yeah. So what I did was I just rewrote this thing, okay, in this way. So this one, if we want to erase also, doesn't matter. Okay, I just circle it. Okay. So I want to actually find out using this, but there are some informations that are given to me. Yeah. The information that is given to me is all the enthalpy change of formation. Okay. Formation of NaHCO3, Na2CO3, CO2, and H2O. They are all given to me. Okay. Now what I need to do is I need to come up, okay, with a few steps, okay, so that I can get that equation. Like for example, I tell you, if I want to form NaHCO3, okay, normally the equation will be, in order to form NaHCO3, 1 mole of NaHCO3, you are forming it by using Na, 1 mole of Na, half mole of H2, 1 mole of carbon, and 3/2 O2. I hope you can actually remember this. Okay, this is going to be enthalpy change of formation. Okay, separate them into atoms. Yeah. So what happens here is, okay, I am going to form, okay, not only 1 mole, I'm going to form 2 moles over here. Okay, so if I want to actually form 2 moles over here, okay, hold on for a while. Yeah. Let me check. Hello, Mr. Samuel. Okay, Mr. Samuel is here. Okay, guys.
Hi, Gopi.
Yes, sir.
Yeah, we have a guest from Dignas to observe your lessons.
Yeah.
It's okay, you can carry on with your
I'll
lesson.
carry on, yeah. Okay, guys. You see here, okay, this is going to be enthalpy change of atomic when we want to form, yeah, when we want to form NaHCO3, okay, we form using those elements. Okay? We form using these elements. So what happens here is we want the to form this, yeah, okay, to form this, we want to form 2 moles of NaHCO3. Okay, so if let's say this is going to be negative 950.8, okay, so Megan, in order to form 2 moles of NaHCO3, do we just use that value or do we actually times by 2?
Times by 2.
Yeah, we need to times by 2. Okay, hold on. I'll just mute everyone. Okay. So guys, so you see here, so when we have this, okay, so we have, we need to times by 2, yeah. So when you times by 2 here, okay, what happens is you need to times everything by 2. It means I'll just use a different ink over here. 2, this will be 2, this will be 2, this one times by 2, cancel, cancel, yeah. So you'll get this. So what I mean is you need to actually rewrite the equation here. What you are going to get is 2Na plus H2, I'm just going to refer here, yeah, plus 2 carbon plus 3 O2 is going to be 2 times negative 950.8. Can you understand this? Yeah, so you are just going to write down, okay, like this. And then, okay, once I have this, I can actually circle this part. Okay, I can circle this part. And you can see that I have some other formations. For example, to form Na2CO3, okay, to form Na2CO3, 1 mole, yes, so you have 1 mole also. What I need is, I need 2 moles of Na, I need 1 mole of carbon, and 3/2 O2 to form this, okay. So what happens is, you can see, I will use the 2 Na, I will use 1 of the C, so remaining there is 1 C, okay. I will use 3/2 O2, okay. So there's something remaining over there. So if you want to actually put 6/2 minus 3/2, there's going to be another 3/2 O2 remaining. So what happens is I'm going to form, okay, Na2CO3. So I'm going to write down, okay, it's 1 mole. So I just put negative 1130.7. Now, I want to actually also form CO2. I don't want to use multiple arrow, okay? In order to form CO2, remaining the C, one of the C that I have remaining just now. And there is also going to be, I need 1 mole of O2, okay? I need 1 mole of O2. So I have 3/2 just now. So I need only 1 mole of O2. Okay. I hope you can still hear me. Okay. My connection is not so stable. But again, I need only 1 mole of O2. So minus 2/2. So remaining, there's still 1/2 O2. Yeah. Now, I am going to actually form carbon dioxide, which is going to be 1 mole of carbon dioxide is being formed. So I'm going to use this value. Okay. So I'll put negative 393.5 over there. And the next one is I'm going to actually form 1 mole of H2O. And how am I going to do that? So whatever that is remaining, you see there is 1 mole of H2. It will react, okay, with half mole of O2 to give you H2O. So that is also going to be, I'm just going to use this value, negative 285 kilojoule. Okay. So that is going to be what is going to happen. Okay, I will share the screen again. Yeah, so it's actually laggy now. Okay, let me actually share it again. Okay, I hope we can see. Okay, just wait for a while. Yeah. So you see, I have written this just now. Okay, I've written this just now, and all these are represented by this arrow. Okay, it's all written already. So now what you need to do is to apply the concept that I taught you earlier, which is going to be, you just put a circle there, okay, which is we are going to look at clockwise equals to anti-clockwise. Thank you, Mr. Samuel. Yeah. Now we will look into clockwise equals to anti-clockwise. So we can change this, okay, clockwise, okay, and then we can see here. Okay, I want someone to confirm this. Ryan, is this clockwise or anti-clockwise?
Clockwise.
Clockwise, yeah. So there is only one anti-clockwise. I'm just going to actually use the yellow ink over here. This arrow, I change into that. Now, we know clockwise equals to anti-clockwise. If I want to calculate the HR for this, the enthalpy change of reaction, you see how it's supposed to be written, enthalpy change of reaction plus, okay, clockwise, yes. So 2 times negative 950.8, okay. So equals to, all these are anti-clockwise. So I'm just going to rewrite everything, negative 1130.7 plus negative 393.5, okay, and then you plus with negative 285. Okay, we will do that. Okay, so I want you to calculate for me what is the enthalpy change of reaction. Someone help me to calculate. Okay, I will also calculate. Okay, please calculate, because we will use this value to compare data. Please double check. Okay, my answer, I'm not sure, but please double check. Okay, I received answer from Owen as well, 92.4. Okay, normally it's kilojoule per mole. Okay, this one I'll just put it over here. So this is going to be the answer. Okay, Let it be positive. You do not ignore the positive sign over there. You must write positive. Okay, if it is positive, yeah, make sure it's positive. Okay, write it down. So this is how you calculate the enthalpy change of reaction by using method number 1, which is by using the Hess's law, and then you use the clockwise equals to anti-clockwise. Now, I will teach you Mr. Gopi's method. Okay, one of the method. Okay, same question. Okay, another method. Okay, now if you look at the enthalpy of change of reaction, what we want. So let's say I copy this, and I'm going to paste it here. Okay, this is enthalpy change of reaction that I want to calculate. Okay, I wanted to calculate this. And I have some other information, which is enthalpy change of formation. Let's say I write it to the left hand side. Yeah. So enthalpy of formation of NaHCO3. How do I write? Okay, to form NaHCO3, I need to form it using Na plus half O2, half H2 plus 1 mole of carbon plus 3/2 O2. That is my enthalpy change of formation. Okay, I'm ignoring the part for the states. I think that one, you can fill up your own. Okay, anyway, this value is negative 950.8. Now, let's actually have a look at the Na2CO3. Na2CO3, how do I form? Okay, they say enthalpy change of formation. I form from 2 Na and then 1 mole of carbon and 3/2 O2. Okay, I'll get Na2CO3. That value is negative 1130.7. Let's actually talk about formation of CO2. You form CO2 by carbon plus O2. Simple as that. So that's going to be negative 393.5. And then to form H2O, you form H2O by H2 plus half O2. Okay, and that is going to be negative 285. Okay, now we will try to rearrange, okay, the equations. Okay, what I want the NaHCO3 to be on my left hand side, but I don't have them in my left hand side. I'm having it on the right hand side, and I need 2 moles. Okay, what I need to do is I need to times everything by 2. Okay, and I need to flip the equation. It means when I change the equation, so I'll just use my another pen here. So you see, I'm going to times everything by 2 and flip. Okay, 2 NaHCO3 to give me 2 Na times 2 is going to be 2/2 H2 is H2 plus 2C. 3/2 times 2 is going to be cancel the 2, you will get 3/2. Okay, since I have done that, my delta H now is going to be, because I change or flip the equation, it will become plus 950.8. And because I times by 2, I need to times by 2. Elizabeth, can you understand this?
Yes, sir.
Okay, once you get this, okay, we will totally ignore this equation now. Okay, because I have a new equation now. Let's actually check the other things in the equation that we want to find. Yeah? Na2CO3 must be on my right hand side. It is on my right hand side. It's 1 mole. It's okay. We keep it as it is. CO2 must be on my right hand side. CO2 on my right hand side is okay. H2O on my right hand side. It's also on my right hand side. No need to do anything. Yeah. Now what is going to happen is you just need to add all this H, because okay, you no need to actually calculate and then cancel whatever that is going to be cancelled, because according to my method, if you add all this, you will get this equation. Trust me. Okay, you will get the same equation. So your answer will be, your enthalpy change of reaction is, okay, negative 1130.7 plus negative 393.5 plus negative 285 plus 2 times 950.8. Can someone help me to calculate? Actually, if no need to also calculate, if you can see the my method, you see negative, negative, negative. Okay, so all this. Okay, hold on, yeah, my screen froze again. Okay, just wait for a while. So here, okay, you can see the method negative, negative, negative. Okay, so here negative, 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 negative. Okay, then after that, when I bring this, it will become positive there, plus. So you can see it's plus there. So anyway, even you use your calculator to calculate, you will get the actual answer, which is going to be plus 92.4 also. And this is faster also, way faster than actually drawing this method. Okay, but I leave it to you which one you want to select. Okay, the option is yours. Okay, which one you want to use. But if they say in the question, they ask you to draw the Hesse cycle in paper 2, you don't have any other option. You have to use this method. But in paper 1, you have a choice. Okay, so this is one of the way to do. There is another way that I will tell you also, the magic method, another magic method that I personally use it, especially when it comes to HF. Okay, especially when it comes to enthalpy change of formation. Now, to use this method for enthalpy change of formation, you need to understand about formation here. To form carbon dioxide, it means the arrow, carbon plus oxygen, the arrow is to form carbon dioxide. You can see the arrow is pointing the carbon dioxide. So you need to actually use the same method over here. Okay, it means that if you have enthalpy change of formation, I will write the equation, I will write certain arrows here. To form NaHCO3, okay, and to form 2 moles, this is going to be 2 times negative 950.8. You need to write like this. To form this, okay, you see the arrow, I'm pointing Na2CO3, negative 1130.7. To form this is going to be negative 393.5. To form this is going to be negative 285. Yeah, this is my favorite method because why? I'll show you. Okay, let's say I'll just bring this over here. Okay, I'll put it here. Now, what I'm going to do is here, somewhere here, I will draw something for my to make you guys to understand. I'll draw a circle over here. Okay. Now, using this method earlier that I show you to try to change the curve, yeah, according to your liking, you can see that if I want to actually change this line into curve, it will go here. Okay. You want to change it into curve, it will go like this. All this, if you want to change it to curve, they will go like this. Why? Because you see my circle is at the center of this over here. So my circle over there is going to actually determine how do I curve my arrows. Yeah. So what happens over here is, okay, I can actually have, okay, use my clockwise equals to anti-clockwise. This is 100% my method. Yeah, Mr. Gopi's method. Okay, you see here, you are going to have clockwise is going to be 2 times negative 950.8. Okay, plus, okay, you want to find this. So let's say I'm going to actually put X. Okay, so equals to negative 1130.7 plus negative 393.5 plus negative 285. You get X equals to, you bring over there, it's going to be plus 2 times of this. Yeah, you will still get the answer that we got just now, which is plus 92.4 kilojoule per mole. From here, you can decide which method you want to use. There are 3 methods. Yeah, there are 3 methods. This method, okay, if they say in paper 2, draw Hess's law, Hesse cycle, you do not have any other choice. You have to draw. Yeah, but if you have MCQ, if you are given a lot of equations, any kind of equation, you can actually use this method. Okay, but when it comes to formation, my favorite method is this one. This is my own method, okay, where you can actually try to put arrows to form. But for formation, do remember, okay, if I have, for example, AlO3, okay, I just give you one example, aluminium plus 3/2O2. Let's say this is delta reaction. Yeah. Now, if you want to form aluminium oxide, okay, you form, okay, maybe there is actually a value for formation of aluminium oxide. But you need to understand, in nature, aluminium is already formed. Okay, in nature, aluminium is already formed. So if you want to find the enthalpy change of formation of aluminium, in, let's say in the question they didn't give, it automatically you need to know enthalpy change of formation of aluminium is 0, because in nature it's already there. You do not need to form, okay, aluminium. The same thing in nature, oxygen is already there. Okay, so elements, I want you to remember this. Enthalpy change of formation of elements are always 0. I repeat again. Enthalpy change of formation of elements are always 0. So if you are using my method, please take note of this. Okay. Enthalpy change of formation of elements are always 0. Okay, so sometimes if they give you certain values and sometimes they don't give you certain value, it is understood it is 0. Okay, you need to actually understand that. Okay, anyway, I have done this. Okay, I just want to ask you whether there is any question for this.